Hi, welcome to this session of time series data analysis. This is the fourth session. Today we'll forecast time series data using linear trend without using moving average or center moving average in Excel. So quickly go into straight away our Excel model. So this is the data we have, and first we'll work out the additive model without using moving average. So we have 5 years of data, 5 quarters, that is simply 20 quarters. So we have a data. So first we'll use what is called a simple trend by taking the regression. So that means we'll just take the intercept and of the given data, comma, this one, the 20 data. Then we have the slope. This is the slope, comma, y, comma, the independent variable. So now, first we calculate the trend. So intercept function f4 plus slope, freeze that multiplied by time. So we got the trend for we got the trend. Now we detrend it from the original data. So this minus the trend. So that will give you the detrended now. Just then we have to calculate seasonality index from the detrended data. How do you calculate? So we have to go to adjusted seasonality index. That means we are going to calculate average of each quarter. That means quarter one for the next 5 years. So how do you take that? You use average if. You take this 20 quarters, freeze them, okay, comma, with the reference to the quarter, comma. So we are going to use the detrended data, again freeze that, minus for additive model. So for adjustment we have to do the subtraction, average of this detrended data, fix that function f4. So now we got that. For each quarter we have the adjusted seasonality index. So you want to check, it has to be 0. So it is 0. Now the next is take the same value here by taking a VLOOKUP. Use a VLOOKUP of against the code. Take the VLOOKUP table, function f4, freeze that, comma 2, because we need the second column, and for exact match we'll take the false. Now we got the seasonality index for all the quarters. We got it. Now we need to forecast it. How do you forecast? Very straightforward. For additive model, T plus S, trend plus seasonality. So we got the forecast. Now we got the error. So y minus y hat, the forecast. That is an error we have. And then absolute error, take the sign of. Then we take the error divided by the y, that will give you the and adjusted percentage error. So now we got everything now. So let's delete this one now. So we can calculate what is the R square, and for the original data y, comma, and this one. So that is somewhere around 89.5. Now we take the mean absolute error. We take the average of the mean absolute without the sign. So that is 3.1. Now root mean square root of, okay, and some square. We take that of this one divided by count of, you can take this one. So this is square root of some square of the error, that will give you what is called the root mean square, and average of percentage error. We will take the average of the. So anything less than 10% is good. Again, we can take that and r squared of the y comma. So for that, the forecast is reliable, strong. So it is 99%. We can also, this is the map. So we can say the accuracy of the model. So this is the error percentage. This is the error percentage. So we can also say what is the accuracy. And accuracy is equal to 1 minus the error percent. It is still 98%. Now we want to forecast for the next 1 year for the four quarters. So we don't have the actual data. We are going to forecast this. So what we can do is that, and the trend we can actually continue the trend. That will work. So we can see that, and this is a linear trend. So we can continue the trend. Okay. Now the next is that we can also continue the seasonality index. That will work because it will map the respective. Similarly, we can use the forecast. So we have the forecast for the next, this one. So this is the forecast for the next 4 years. Now we can also and put a color here. Now let me highlight everything so that we'll take the graph here. Whatever we don't want, we remove that. So insert graph. Now we will remove this one. Delete that. We'll remove the seasonality index also. So now we can see that we got the actual data, and so we have the trend. The red one is a trend, and we have the actual forecast. So we have the actual forecast, everything. So this is how we can do the what is called additive linear forecast. We'll do similar thing. We'll do in a multiplicative one. Same thing we'll do, and so I have got that, and same intercept and the slope. So I don't need to change that. So that means intercept function f4 plus slope into function f4 into the time. So we got the trend, the same trend, we got it. Now here for a multiplicative model, we have to detrend it, divide y trend divided by y divided by the trend. So y divided by t. So that we have a detrended data. So we have the detrended data, and then you have to use a seasonality index. So how do you calculate seasonality index? Is equal to average if of these quarters, 20 quarters, so function f4, comma, take this one, comma, then the detrended data, that is function f4 divided by, for multiplicative we have to divide it by the average of the detrended data, function f4. So we have an average if this one, and okay, control C, control V. So now sum has to be 4 for 4 quarters. So that is correct. Now the actual seasonality index, use the VLOOKUP formula. So first the quarter reference, then VLOOKUP table, function f4, comma, second column 2, then we have the exact match false, then we have what is called the seasonality index, that is filled for all the quarters. Now the forecast is trend into multiplicative trend into seasonality index. We got a trend into seasonality index. So what is the error? Y minus the forecast, that is y hat. This is your error. Absolute error is just take the sign of ABS. Then similarly, what is the error percentage? Absolute error divided by the y. So just double click that. Now, so we want only that for the actual period. Now we have you can see that this is the mean absolute error 4.5, root mean squared, so that is 6.32. The average and mean average percentage error, then we have accuracy is 1 minus this one, and we can also have a how far the forecast is strong. So we can put R squared of the actual data, comma the forecast data. So you can say it is nearly about 99.7% accurate. Okay, now again we want to forecast for the next period, so we can copy the linear trend that can come similarly, and we can copy the forecast. So that means forecast is nothing but and y trend into seasonality index. So we got this one. So this is your actual data, and so you can again you can highlight everything and you can put it as a graph. You can remove what is not required from the graph. So you can remove this one and it's not required, and so you can see that this data and this is the forecast, and this one is a linear trend. So the original data and the forecast data is almost same, so that is why the graph is followed. So let's go for one more thing. How do you do a monthly multiplicative model? So we have a monthly data of nearly about 60 months of monthly data of a sales of a company. So first take what is called the linear trend. So how do you do so? Quickly we'll take the intercept. We'll take the intercept of y comma the period, the time. So we want to only use the 60 things, and similarly we can also use the slope. So now similarly this one, this comma the 60 months. So I got that. For the linear trend, I have the slope and the intercept. First is equal to intercept, freeze that function f4 plus slope into multiplied by the time. So we have the linear trend for the 60 or on hours. Now next is a detrend. How do you detrend? Y divided by the trend. So that is a detrended. Then we have to calculate seasonality index for that. So what we'll do, we map it January to December. We have the months. So I'm going to calculate adjusted. So how do you calculate? Average if take this entire months, the 60 months, put freeze that function f4, then the reference each month, then take the average of the detrended data, again freeze that, and since it's a multiplicative model, I'm dividing it for adjustment, average of the detrended data, function f4. So now we got that and adjusted seasonality index. Now if I add it, it should come as 12 for 12 months. So that's a check. Again we do the VLOOKUP, and VLOOKUP of the respective months, comma the lookup array, again freeze that function f4, comma the second data we need, comma the false for exact match. So now we got the seasonality index. Now the forecast is very simple. So trend into multiplicative model, trend into seasonality index. So we got the forecast, and then we can calculate the error, y minus y hat, the forecast. Now we can take the absolute error, then we can take what is called the absolute error divided by y for percentage error. So double click that. Now we have 60 months, so delete this one. So now we got all the data. Now the intercept is there. The R squared of that, what is called the original trend. So it's RSQ of this one, comma. So this will give you the original trend. So that is it. You got R squared is 88%. Now what is the average? Mean average error. So mean absolute error. So take this one, mean absolute error, that is 3, and root mean square root of some square of this one, the original error, and divided by count n. Count is the same thing. That is nothing but x minus x bar and the whole square. So you got the root mean square. Now we have the average of the error percentage. So here MAPI is a mean absolute error percentage. So that is nothing but 1 points. So that when the error is this is the error percentage. So what is the accuracy? The accuracy is equal to 1 minus this one. Now we can also calculate what is the R squared of the forecast with the original data. So the original data, comma, and the forecasted data. So it is 99%. So that is how far the forecast is strong, very reliable. So now we got what is called, so we want the forecast for the next 12 months. So automatically we can see that forecasting for the next 12 months it is there. So this is your linear trend, and it's not required. Now this is your sensitive index. So that means multiply the trend into the seasonality index, you'll get the forecast. So thank you very much for watching. So next session, what we'll do, we'll start discussing and ARIMA model basics. So we'll discuss what is ARIMA model. So thank you very much for your patience. Thank you.